Okay, what we're going to talk about here is why the second derivative test works. Now, this is not the second as in we're using the derivative a second time. We're actually taking the second derivative and trying to use it. Now, it only works if you know the first derivative exists, right? Because you have to be able to take a second derivative. So we always start out by saying, if the first derivative at a point is 0, remember that's a critical point, and you happen to know that the second derivative is positive. Well, let's just, in the middle here, just put a little picture of what happens here. Yes, if the second derivative is positive, you know you're looking at part of a smiley graph. If you're looking at part of a smiley graph where the derivative is 0, you've got to be here, right? And that's just going to tell us that P is a local min. Local min. And that's the first part of the second derivative test. Let's look at the second part. The second part says, if you're looking at a second derivative that's negative, well, you know the graph has to look like that. It's got to be concave down. So this says if you're looking at a part of a concave down graph and you're looking at a critical point, you have to be here, right? That's going to say P is local max. Is local max. Yay. Now, what can go wrong with a second derivative test? Well, first off, there might not be any second derivative. That actually happens with one of the problems we just did. So if there's no second derivative, you can't use the second derivative test. What else can go wrong? You can have lots of things. For example, if you look at the graph of y equals x cubed, it looks like this. Right? Hey, this is actually a critical point, and the second derivative is 0, and it's not a local max, and it's not a local min. Right? It's neither. If you look at the graph of something like y equals x to the fourth, you're going to see something like this. And the first derivative is 0, the second derivative is 0, the third derivative is 0, right? And it's a local min, right? If you look at the graph of minus x to the fourth, it's going to look like that. The first derivative is 0, the second derivative is 0, the third derivative is 0, and it's a local max, right? So the problem is if the second derivative is 0 and the first derivative is 0, anything can happen. And usually they say the test fails, and what it really means is we have to try something else because we're never allowed to just stop and not classify whether a critical point is a max or min or neither.